Good afternoon, students. Today we are going to discuss Unit 5 VLSI System Design on topic CPLD and FPGA. Okay, so let us see first CPLD, that is complex programmable logic devices. Okay, so in short we will call CPLD, right? Okay. So in the last class we have discussed PLDs, right? So PLDs. What is the PLDs? We discussed PROM or ROM, PAL and PLA. Okay. So these are consist of two-level programming, that is end programmable whatever, okay, or R, right? So PLDs are also called, we discussed in the last class, also called SPLDs, right? SPLDs is nothing but what? Simply I can say simple PLD, simple programming logic devices. Why? Because these SPLDs handles or contains what? 10 to 20 logic functions or blocks, whatever you can call, okay, which consist of 10 to 20 only, right? Suppose I have more than this logic circuits or logic function blocks, then it become a complex circuit, right? So for more complex, circuits, okay, for more complex circuits, generally we can call that circuits as a complex PLD, or simply we can say CPLD, right? So which is generally CPLD contains what? CPLDs are contains PL, PLA and ROM also, right? So n number of more than this 10 to 20 logic circuits, more than this we have all together interconnected, okay, as a CPLD. We become a complex programmable logic devices, okay. So they are more complex, okay, and have the architecture features both PAL and PLA are interconnected, right? And see, in this architecture we have small building blocks called macro cells. Anyway, we are going to discuss in detail macro cells, okay. So macro cells contains logic for implementation, okay. So these are logic which contains logic for implementing, okay, disjunction normal form expressions, okay. So which is nothing but it contains a logic which is having generalized Boolean expressions, okay. Generally it is called distinctive normal form of expressions, okay, right. And also macro cells which are consist together are 80 to 16 macro cells generally. Okay, so anyway, the block diagram we will discuss, and these macro cells continue functional blocks. Okay, or generally it is called logic array blocks also. Okay, right. Let us see the basic architecture of the CPLD. Okay, so okay, we'll see the basic architecture of the CPLD. Okay, let us see. So we have IO block, and this is interconnect array. Or interconnect matrix also it is called. Okay, and this is again IO block. Okay, so IO pins generally input output pins. Okay, for this we have, so this is functional blocks. I'm writing as FB. So number of blocks are connected together, FB, right? Okay, so these are connected like this, which is interconnect matrix or array is connected to functional block, okay, which is connected to IO input output functionality. Okay, so like this. Okay, so I draw here also FB. Okay, FB is nothing but functional block, right? So like this is connected, and see these outputs are again back to interconnect matrix. Generally global interconnect array or interconnect matrix generally we call. Okay, this one. So which is consist of PLA and PAL, right? Like this. Okay. Sorry. Right. Okay. So this is a basic structure of CPLD. Okay. So which here just see the functional blocks contains what? ROM, PLA and PAL only. Okay, they are interconnected together, right? And it consists also macro cells. What are the macro cells? We'll discuss, right? So it consists of multiple blocks. Suppose this is I functioned with some functionality, and it is also functioned with other functionality, like that. I can give individually n number of functionalities, whatever I required. Okay, these functional blocks. Okay, and the output of the functional block going to the uh, interconnect array. Okay, so interconnected array is used for IO functions to interchange the functional blocks. Okay, so they will interchange the functional blocks outputs. Okay, So yes. So this is a basic structure consists of, so randomly drawn here. Okay, so generally consists of input output functionality. So this is dual one, output functionality and functional blocks. Functional block consists of this ROM, PLA, PAL and macro cells. Okay, which is consist with of interconnect array or global interconnect matrix also it can call, right? So let us see the one of the example architecture of the CPLD. Okay, let us see one of the example of CPLD. Okay, so this is Xilinx XCR3064XL. Okay, structure or architecture. Okay, so this is a manufacturer Xilinx. Okay, XCR3064XL. Okay, so this is the architecture of this one. Okay, let us see the functionality of this one, right? So here see we have input output functionalities. Okay, this is input output blocks. Okay, or pins we can call. And so this is the functional block which is consist of macro cells. Okay, so in this case we have macro cells are 16. Okay, now functional blocks are 8 functional blocks. Okay, 1 2 3 4 5 6 7 8. And whatever the interconnect. Okay, so generally this is interconnect array. Okay, so which is consist of all end array logics. Okay, end or logics here consist. Every logic block or functional block executes a specific function. Okay, so this is a one specific function we have, this is another specific function, like that we have n number of specific functions. In this case 8 different functions we have, right? And which is consist of macro cells. Okay, so all of the macro cells in a functional blocks are fully connected each other. Okay, these are connected together with a certain functionalities. Okay, which is consist of say mux and flip-flops. Okay, and end gates, R gate, end R logics will be anyway executes, and buffers and inverters. Okay, see actually CPLDs are we have combinational as well as sequential circuits. Okay, to get the output. So therefore flip-flops also included in this case if required. If required, my functionality will be as a memory storage, then becomes we can use flip-flops in this case. Okay, so see here so macro cells are directly connected to the IO block. Okay, that is input output blocks. It is consist of input as well as output. Okay, right. So and the output of the functional block or macro cell functional block, okay, it is reconnected to the interconnect array. Okay, so already I given interconnect array is used for IO functionals to interchange the functional blocks input output functionalities. Okay, so here also all are reconnected to the, or the output of the functional block is reconnected to the interconnect array or interconnect matrix. Okay, so this is basic structure of Xilinx. Okay, this is already Xilinx. Okay, one of the model architecture of the CPLD, right? So let us see the macro cells, right? So what macro cells functionality and how it works. Okay, got the point here? So this is basic function. See, CPLDs are we have IC packages are number of IC packages we got. Okay, so one of the IC packages is Xilinx. Okay, so Xilinx we have 700 series, we have 900 series. Okay, so this is the one of the series, right? Okay, so let us see macro cell. Right, let us see the macro cell. Every logic block or functional block executes a specific function. Okay, so this is one specific function we have. This is another specific function. Like that, we have n number of specific functions. In this case 8 different functions we have, right? And which is consist of macro cells. Okay, so all of the macro cells in a functional blocks are fully connected each other. Okay, these are connected together with a certain functionalities. Okay, which is consist of say mux and flip-flops. Okay, and end gates, R gate, end R logics will be anyway executes, and buffers and inverters. Okay, see, actually CPLDs are we have combinational as well as sequential circuits. Okay, to get the output. So therefore flip-flops also included in this case if required. My functionality will be as a memory storage, then becomes you can use flip-flops in this case. Okay, so see here, so macro cells are directly connected to the IO block. Okay, that is input output blocks. It is consist of input as well as output. Okay, right. So and the output of the functional block of macro cell functional block, okay, it is reconnected to the interconnect array. Okay, so already I given interconnect array is used for IO functionals to interchange the functional blocks input output functionalities. Okay, so here also all are reconnected to the, or the output of the functional block is reconnected to the interconnect array or interconnect matrix. Okay, so this is basic structure of Xilinx. Okay, this is already Xilinx. Okay, one of the model architecture of the CPLD, right? So let us see the macro cells, right? So what macro cells functionality and how it works. Okay, got the point here? So this is basic function. See, CPLDs are, we have IC packages are number of IC packages we got. Okay, so one of the IC packages is Xilinx. Okay, so Xilinx we have 700 series, we have 900 series. Okay, so this is the one of the series, right? Okay, so let us see macro cell. A signal generated in the PLA is routed to an IO pin through a macro cell. Macro cell. Okay, so general functionality of the macro cell is that. Okay, so let us see the structure or design of macro cell. Okay, see here, any one of these pins here, in this case 36 pins are given. Okay, for design of the Xilinx. Okay, so in this case see CPLD functional block and macro cell, this version is XCR3064L. Okay, which is represented with developed by Xilinx. Okay, right. So see here, initially these 36 pins, any one of the pin is connected to this. Okay, buffer or inverter. Okay, which is the inputs of AND gate. AND gates are here 48. Okay, so this is ANDer operation only connected together. Okay, then see, uh, each OR gate can accept up to 48 product terms. Okay, which are from AND gate, right? So these 48 product terms, it will accept the OR gate. Okay, this is a PLA, same operation. Okay, PLD's operation, whatever the PLDs we discussed in the previous class, right? So see here we have mux. So generally mux has select line. Okay, so whatever the function, the output function of the OR gate. Okay, So if you want complement, it will goes, and this is selection line. Through selection line we can take any one of the functionality. Okay, then see here, next is we have, so from here we have one output, right, to IA connect. Again see here, this is directly going to another mux2 here. Okay, and we have flip-flop. Okay, flip-flop whenever as per requirement of my circuit. Okay, so if I want memory storage, then I will go through flip-flop. Otherwise it is direct bypass to the another mux. Okay, this is a selection line, whichever I want I can select. Okay, right. So these two are programmable select lines. Okay, muxes are you are using here programmable select lines. Okay, so to select either I want complement or direct the function of OR gate, I can. Okay, so this output, okay, this output will go to again IA. Okay, that is interconnect array. Okay, so here we have a buffer. Okay, programmable enable. Okay, which goes to the again IO pin. Okay, so this is the functionality, and this will reconnect to the input level. Okay, this IO block again reconnect to the input level, so whatever the functionality which we require further. Okay, so this is a macro cell operation, which is nothing but PLDs only. Okay, so n number of PLDs, this is one macro cell we have. Okay, out of 36 pin, any one pin is connected here. So like that we have 16 macro cells in a previous CPLD design. Okay, so like that each functional block consists of 16 pins. So this 16 pins, 8 functional blocks totally in this case. Okay, so each one consists of 16 macro cells. Okay, so this is generally designed functionality of CPLD. Okay, so here this is a part of PLA, right, and this is simplified macro cell. Okay, this functionality, right, and this is output, output function blocks. Okay, so this is the basic operation of the uh, macro cell. Okay, right. So in this case the output functionality IO, what will happen when the IO pin is used as an input, then the buffer must be disabled. Okay, so when it is useful as an input, then buffer must be disabled, directly it is connected. Okay, so like that this is the design of the macro cell, which is consist of CPLD functional block, right? Okay, next we will see FPGAs. Okay, so let us see the FPGA, which is nothing but field programmable gate arrays. Okay, shortly called FPGAs. Okay, what is FPGA? Okay, it is an IC. Okay, as you know, it is an integrated circuit. Okay, and which is configurable or I can say programmable. Okay, function blocks consist of, right? So generally the components of FPGA is basically logic blocks and interconnects. Okay, so in this FPGA completely we can configure our program, or we can programmable all logic functions or interconnections. Okay, what are the blocks contains this FPGA. Okay, so this is a great feasibility which gives us FPGA. FPGA is wonderful design as per my knowledge, okay, so which is very easier to program, okay. A chip, a design can be easily programmed and uploads, right? So it is like as easy as software, simple I can say, as easy as software, okay. So another the term, if I go with the term programmable field programmable. So what is the field programmable? So programming in the field, particular field, okay, I can say, uh, see simple, uh, programming whatever the program we are doing, okay, with various high level languages, okay, in the field, which means what, modifying the device function in the lab itself, okay. So programming in the field means modifying the device function, whatever the functions we are modifying, okay, writing new programs, okay, within the lab itself. Or I can simply say that, or I can simply say that at the site where the device is installed. So we can program at the site where device is installed. It is very simple. For example, suppose I have certain block, okay, I'm considering here only single block, okay, single logic block I can say, right? So this block, if I return a program, suppose say addition, okay, or subtraction, etc., okay, so we can modify the function within the lab only, okay. So we can modify by the functions or logics within a lab or within a device, okay. So we can modify, very simple, okay. So that is called generally programming in the field, okay. Now, so generally FPGAs are inexpensive, so I can say FPGAs are inexpensive and very easy to realization, I can say easy realization of logic networks, okay. So as I said, they are inexpensive and major part is, see, easy realization. So as per my knowledge, this is a wonderful technology introduced by the world, right? So yes, um, so generally what these realizations will be done in the hardware itself, okay. So in hardware, okay, right. I can say this realization will be as easy as software. So I'm comparing this, okay, not done in software. So this relation will be as easy as of generally software, okay. So basically students are verifying their programs, verifying their projects, whatever they did, okay. So in the laboratories by using FPGAs, you can, even students in the college also we can use. Generally we have, I think, a Spartan 3 Xilinx we have in the laboratory devices, okay. So we can program your own program. Most of the students, final year students, will upload their program for the project purposes. Okay, so FPGAs are very useful, I can say, right? And so let us see hardware. So which hardwares FPGA contains? Okay, so hardwares of FPGA, whatever the values. Okay, uh, one. So as I said, these are PLDs only. Okay, like CPLD. Okay, and logic gates. Why logic gates? So endor operations we are doing. Okay, so logic gates we'll use, and RAM here. Okay, so SRAM based architecture will be available in this case, and other one is any other devices you can say. Okay, so I can say remaining other devices. So three levels, three stage buffers will be there. Okay, like etc. So these are the hardwares in FPGA. Okay, so in FPGA layout, let us see that in FPGA layout, basically, for example, if this is a layout, okay, so uh, the layout of unit is repeated in matrix form. Okay, so generally, suppose I have one logic block, another logic block, another logic block, another logic block, another logic block, like this. Okay, so these are repeated. Okay, repeated in matrix form. Okay, so I written here, for example, here also the n number will be there. Okay, so these layouts consist of CLBs. Okay, so which are functionally uploaded. Okay, functionally filled, right? Now we'll see the user configuration. User configuration. So generally user config. So I can say uh, user can be function each logic block, input output. See, everything is programmed in this case. That is a greatness of FPGA. So I can say can function of each logic block, and can function input output operations also. Okay, and also interconnections. So here interconnections also programmed. Okay, generally interconnections are programmed with SL. Let us SRAM, we will discuss that also. So three basic concepts are used for interconnections. One is pass transistors. Okay, another is transmission gates, another is mux. And already we seen concept of mux in the CPLDs also. Okay, same here. Okay, generally mux contains selection lines. Okay, so from that selection lines, whatever the functionality we required at the output level, okay, we will get that. Okay, so uh, so let us see, there are many vendors which provide FPGAs. Okay, so I can say there are many vendors which provides FPGAs. Okay, so for example, if I consider, so if I take FPGA family, the family of FPGA, then we have Xilinx. Okay, then Actel, then we have Altera. Okay, so on. Okay, so basically, so what is the difference? These are vendors, different vendors are families of Xilinx, I mean FPGA. Okay, so see, functionality will be same. Okay, the functionalities will be same, but the physical design is different. Okay, so for each and every vendor, okay, have the different physical design. So I can say physical design is different from each other, okay. And I can say for implementing programs are also different, okay. So implementation of programming is also different, okay. And the interconnection arrangements also. So interconnection arrangements also different, okay. And I can say basic functions of function blocks also, I mean logic blocks also different. See, arrangements are different, okay. Operation will be same, okay. So basic uh, functions functionality, I can say, of logic blocks are also different, okay. So we have all our famous vendors here, okay. So these are the differences between these vendors, okay. You can say design aspect, connectivity, appearance of design, okay. So these all are different from each other, okay. Right, let us see. So we'll see the basic architecture of some disturbance, okay. Right, let's concentrate on lecture. So see, basic FPGA structure, or I can say architecture, okay. Right, okay, let it be. Right, okay. So basically programming configuration configures logic blocks to a logic functions, okay. So I will show the how it will looks. Configures logic functions, or I can say logic blocks to a logic functions. So see, every block, every connection, every input output devices are programmed here. Everything is programmed. Okay, that is the greatness of FPGA. And we have different techniques, methods to follow the architectures. Okay, SRAM based and anti-fuse. One confusion is there whenever I would like to discuss with the anti-fuse technology. In this technology, once you programmed, it cannot be erased. Still, I don't know how it is possible in FPGAs, because FPGA means erasable. You can erasable your program. You can rewrite the program. You can, so it's very easy. Okay, but in antifuse, there is no possibility after writing a program. It cannot be erasable in that technology only, that method only. I don't know, right? So let us see here basic architecture. I will show initially a simple programmable logic block. Okay, a simple programmable programmable logic block, functional block also it is called. Okay, logic block. Let us see that. I will show the images also. Don't worry about it. Right. So this is my, sorry. Uh, this is my functional block or a logic block. Say, okay, this is uh, logic array block, CAB we can call generally, or functional block, okay, FB, okay, right, which consists of, for example, this is it is use 3 input n number of LUT, okay, I mean LUTs, okay, lookup tables it is, right? So if we take this is output as a Y, and we have so many devices are connected here. In this case, I'm connecting MUX, okay, and which is having another input. For example, this is input 1, 2, 3 input. I said, right? A, B, C, 4 input basically. This is D, okay. Mux consists of another one, and this is say flip flop, okay, memory device, right? So this is as usual clock for this one, okay. Now this is another function, say Q, okay. So this is our simple programmable logic uh, block, okay. So in this case, see the operation. So whenever you give an input, okay, whenever you give input, lookup tables will due to ABC inputs will select any one operation in this, and it will be sent to, okay, directly to the output, okay, that is a logic block output, I can say, right? And if I want to, this is a sequential circuit, okay, then uh, for mux we have selection lines, okay. So this input is connected to the mux, and also another input if required, this one, okay, then mux will be select any one of these and it's sent to the memory device, okay. From that you will get the output, okay. So as we discussed in CPLD only, same, almost same, but in this case we are using lookup tables. So what is the lookup tables actually? See here, for example, say I'll give a small example here. Lookup tables, that is already you know, I think this one concept will recall once again, okay. So lookup table, for example, if I take one small example here, okay, then see what will happen. Two inputs only I'm taking in this case, so 0 0 0 1 1 0 1 1, okay. For this I have certain function output, okay. So that output will be any output, say 1010 randomly taken. This is my output, okay. Programmed output this is, okay. So then what will happen in the, sorry, 1 minute. Uh, in the lookup tables, ABCD inputs are acts as a, suppose this is my output 1010, okay. Then whenever A, B are given, suppose A is 00, then the first line will be selects, okay. This is my output now, okay. This is my output now, okay. So here ABs are acts as a memory addresses, memory addresses, okay. So like this, if next is 01, okay, ABs are inputs are 01, then the second memory is selected, okay. This will be at your output level. Like that lookup table acts, okay. For in the above also same thing, okay. Whenever these inputs are ABC inputs are acting, then automatically lookup table look at into it, and whatever the memory you required, output you required, that you will send to output, okay, or mux, okay. So this is a basic simple programmable logic block, okay. What otherwise let us see SRAM based example I will give. One of the technology in FPGA example, another example I will give for better lookup tables, okay. Suppose my function is A and complemented C, for example, okay. Complemented C, A and B, B small b only I will take, A and B operation, this is A and B, okay, of complement C, okay. For this one, say for example, required function is, required function, say the design A B C, okay. So this is end operation, okay, and this is odd with complement odd, okay. So I am adding inverter here, sorry. ARD. These two inputs are ARD. Okay, this is my output function. Okay, then how this lookup table function? Okay, so for example, for this one I have a truth table. Okay, which is say uh, A, B, C, and output Y. Okay, then these values should be 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. Okay, so these are, if you take decimals, okay, so 0 to, I mean 0 to 7. Okay, so consider these decimals 0 to 7, right? So in this case output function will be any function which you like, I mean which you required, 0 1 1 0 1 0 1, like that, any function depends on this. Okay, then how programmed the lookup table? Okay, so you can say programmed lookup tables. Okay, so these are so if I take SRAM cell based, then basically SRAM cell will be like this. This is 1 2 3 4 5 6 7, I think. Okay, same blocks. So whatever the output values will be stored in SRAM cell 0 0 1 1 0 1 0 1, like this. Okay, and it is connected to the multiplexer mux. In this case 8 inputs, so 8 into 1 mux. Okay, so this is 8 into 1 mux in this case, and we have a selected lines A, B, C are selected lines in this case, right? So the function is realized in such a fashion by selecting A, B, C. Okay, so these functions are connected like this. Okay, so this is SRAM cell, one of the techniques. Okay, so whenever your truth table output, it will stores into the SRAM cell, which is connected to the mux. In this case, 8 into 1 mux, and you will get the output Y. Okay, so in this fashion lookup tables functions. Okay, so suppose my output will be ABC, will be say um, for example this one. Okay, then here is high, this one it will be select here. Okay, so whatever the value, this is selected and this is means to output level. Okay, so output of the lookup table. Okay, whenever given your input. Okay, for this logic function, whenever given your input, for example this one. Okay, this a b c r, this is the function, then automatically it will select in the SRAM cell. Okay, and automatically it is selected due to with selection lines, this output will be resulted at the output level. Okay, that is the basic idea of the lookup table. Okay, so which is used in the say programming logic blocks. Got my point? Is it okay? So this is the one of the best examples. Okay, which how will be the lookup table functionality. Okay, in the FPGA of logic blocks. Okay, right. Now, what is the programmability in FPGA? Let us see the programmability in FPGAs. Okay, right. So, as I discussed, there are three programming methods used in the FPGAs basically. So, right there, there are three programming methods or techniques, you can say, used in FPGAs. Okay, so that are, I can say, the first one just now we discussed, SRAM based. Okay, so second one is anti-fuse antifreeze technology. So third one is EPROM, EPROM. Okay, right. See here, in this case, uh, we have, see, SRAM based is a wonderful technology. Okay, generally, the vendors which are following this technology are Xilinx and say Altera. Okay, this technology and this antifreeze technology is used basically in the industries most of the time. So these are used vendors are Actel and you can say Quick Logic. Another vendor is the Quick Logic, etc. And these two will be EPROM or EPROM. In this case, these technologies are not used in. We can very rarely it will be used. Okay, so not used in the most common vendors. Okay, this technology, right? So we will discuss these two here. Uh, so I'll give the brief introduction about these two programming methods in FPGA. Okay. So before going to this, I will look at into basic architecture of FPGA. We will look at into it. FPGA architecture. Okay. Just we'll go through it. Okay. The basic architecture of FPGA. Okay. So here it is. So this is the complete architecture of the FPGA, the basic one. Okay. So okay, right. So see here, these are connected. Okay. So together with the help of interconnections. Okay. So these are all called configurable logic blocks. Okay. And see SRAM, these blocks are, see in this case, these blocks are SRAM cell blocks. Okay, so and these are input output pins. We can call the input output blocks. Okay, these all are okay with our programmed. See, everything is programmable here. Okay, so these logic blocks which are contain macro cells. Okay, in this case. Okay, so these everything is programmable in this case. Okay, okay. So this is the basic architecture of the FPGA, right? So we will discuss what is generally the different techniques, methods. Okay, right. See this one of the SRAM based FPGA. Okay, Xilinx SRAM cell based FPGA. Okay, so in this case, okay, so these are the interconnecting wires which are routing, right, routed, and this is input output blocks, and this is CLBs. Okay, or functional blocks we can say. Okay, configurable logic blocks. Okay, so this is SRAM based one. Okay, so now we are going to discuss Xilinx SRAM based uh, one of the technique, that is method for a programming. Okay, so internal structure of the FPGAs, just now these will be looks like this. Okay, so this is a generally programming interconnects. Okay, with the functional block. Okay, and these are the logic blocks. Okay, inside the logic blocks, so this is the functionality which is consist of AND OR and flip flops and muxes. Okay, and lookup tables. Okay, these are the lookup tables, right? So from this we can develop our inputs. Whatever the inputs we can program, and that inputs will be connected to the other logic blocks. Okay, So like that, each and every function we have specific logic functions, okay, connected through interconnects from uh, each and other, right? So this is IO blocks, okay, which are connected. So here like this, okay. So these are also programmed, okay. These are also programmed. This is the internal structure, basically how it will be looks like a FPGA, okay. Now, right. Now we'll see the first technique or method of SRAM SRAM based programming. Okay, SRAM based programming. How it will be, right? Okay, right. Okay. So basically, FPGA connections in this in this FPGA connections are designed with say pass transistors. Already given in the CPLDs also, the switches will be transistors only. Here also pass transistors and transmission gates, and as we know, multiplexers. Okay. So how it will be programmed actually? Just see here a small example I would like to give. The basic idea I would like to give. These are the interconnects. Okay. These are the say interconnects. Okay, vertical horizontal lines, okay. So how will be interconnected? Suppose say this is interconnected, this is interconnected, this is interconnected, this is interconnected, okay. So how will it looks like, okay. So here, this is, suppose if I take this one here, right. One minute. Here, then this will be looks like, the block. This is a, it's not selected, right. This is a connection, suppose, okay. So like this, here the pass transistors are connected, okay. Here we can program a SRAM cell, okay. So in this case, if SRAM cell is 1 or 0, I programmed, when it is 0, this is open circuit, which means it is not connected, okay. And vertical and horizontal interconnects, okay. Then if it is 1, then it is connected, pass transistor, okay, passes the values here from here to here, therefore this is connection, okay. Like this it is programmed, okay, the interconnect connections in the FPGA, okay. So these three, this is pass transistor which I shown here. Like same, uh, here we can, by using this programming, we can make making connections or breaking connections, okay. So here is a feasibility we have, making making or and breaking connections, okay. So using these technologies, if you want to see how these three looks like, this is a pass transistor technology. As we know, it is connected with SRAM, which is programmed SRAM, input and output in this case, okay. And a transmission gate, if I look at into transmission gate, then it is programmed like this. And here you can say general design I'm drawing here, okay. So here it is connected here it is connected, here it is connected SRAM. So, and we can program here. Okay, due to that, this transistors, okay, this transmission gate will get the resultant, right? Like that, as we know, MUX, okay, just now already we discussed the MUX SRAM cell concept, MUX, okay. So SRAM cells will be programmed here, okay, with the connection of MUXes, okay, and these are the select lines we have, right? So whatever the MUX type, this is MUX, okay. Then these are the inputs. Already the whatever the functionality outputs is stored in the SRAM cell, okay, which are programmed, okay. Then depends on that, selection lines will get the output, okay. So these three methods we have used in the connections, okay, which one need to connect, right? Okay, now SRAM cells, if you go into the not depth one, but how it will be implementation of program basically. Okay, basically SRAM cell consists of a single shift registers. Okay, for example, this is a single shift register. Okay, which is consist of pins. Okay, these are configurable pins, we can say, and like this, we have a serial blocks will be stored in the shift register, and the functionality will be shifted like this, okay. And these are the configurer pins, okay, variable pins, okay. So generally what happened here, I want to implement my logic, okay, then it is configurable, in terms of bit files, okay. So bit files, in terms of bit files, for example 0010, like that would like to store. This is a single shift registers, okay. Like that we can this is SRAM cell only, SRAM cell, okay. Like this it will be passes shift level, shift wise, okay, information to configurable pins, okay. So like that it will store in the bit files, okay. So like that the SRAM based technology is programmed in the FPGAs. Next is this is very interesting one. uh, Let us see, okay, let us see, anti-fuse technology is another method, programming method of FPGA, okay. So here see, I already discussed with this one time program. How it is possible, I don't know still. uh, Here one time program technology, programming technology, we can, so this is one time program technology, we cannot repeat, okay, reprogram, I can say, we cannot reprogram this, okay. So this is one type of I can say uh, confusion which I get. Basically, FPGAs are uh, programmable. Okay, we can program and erase. We can program whatever the functionality we required. But anti-fuse technology says that this is one-time program technology. Okay, once you write the program, cannot be erasable. Okay, so Generally, let us see just a brief idea of this one. Generally, it contains of links in configurable paths. Okay, basic. This is like look like this paths. Okay, configurable path generally called. Okay, generally it consists of metals, which is two metals in between this block is represents. For example, I'm just giving just idea of this one. Okay, so just to see here. Mm, for example, this is a block. Okay, right. So for example, this is a block. Okay, so this is a metal one, and this is a metal two. Okay, whenever given this is remaining things will be in these oxide layers. Okay, this is right from this is oxide layer. Okay, and whenever given high voltage, okay, then this will be conductivity starts from here. Okay, then see, then it will looks like this. It will look like this, and this is metal one, and this is metal two, and these two will be opens like this, and it is starts conduction from here. Okay, this is metal one, metal two. Okay, like this, right? So when apply high voltages, this will be happens. Okay, and it is acts as a open circuit, right? So when unprogrammed, generally these paths are whenever you are not programmed, then it contains like a high resistance value. Okay, so therefore if you program this one, it become a starts conduction. Okay, from this one this become an open path, right? So this is one of the basic example of antifuse. Remember, antifuse technology is one time technology, one time programming technology. Once you return, it cannot be taken back. Okay, so this is fixed one, you can say. Okay, so right. And see, vendors, we will look into vendor specifications. Okay, so everything is completed. Let us see the one of vendors. Okay, for example, Xilinx is the most popular one. Okay, we'll see the specifications of this one. Okay, we'll see the specifications Xilinx. Okay, so in the Xilinx we have Vertex, Vertex 2, and Spartan. Spartan we have in the laboratory. This is we have in the laboratory Spartan 3. Okay, so let us see the blocks which are contains. Uh, all Xilinx FPGA contains, the first one is um, CLB, and the second one CLB is configurable logic blocks, and IOB, input output blocks. Third one is PI, this is a programmable interconnections, and fourth one is SRAM blocks. Okay, SRAM blocks, and fifth one is other resources or other devices, other resources, I can say. For example, three state, I can say three state buffers or global buffers, etc. Okay, right. So this vertex 2, just now basic architecture I shown you that. We'll look into it once again. Where is it? Once again we'll go through that. This before I start this, right? This one, SRAM based architecture. Okay, so this is a is one of the vertex. Okay, so same, this is a output input blocks. Okay, IO blocks, these are what happened, it's not selecting. These are IO blocks. Okay, and uh, okay, and we have in this is not representing SRAM blocks also will be there. Okay, SRAM blocks also will be there. Okay, doing the interconnections. Okay, and configurable blocks. Okay, which are connected to all interconnector connections. Okay, each and other will be connected, and these will be contains. Okay, macro cells. Okay, so this is the basic architecture of the uh, you can say, okay, vertex, right? Okay, so sorry, all right, yeah. So this is the basic structures of FPGA. Okay, so further blocks of FPGA Spartan 3 and all other variants, Xilinx 4000, 7000. Okay, see these Xilinx FPGAs. Okay, the blocks will be I will send to you. Okay, so that you can able to understand the blocks how they look like. Okay, so this is the concept of programmable field programmable gate arrays. Okay, so this is a wonderful concept. Field programmable gate arrays are generally all blocks are programmed in the design, and n number of blocks are consist. Major blocks are configurable logic blocks, IO blocks, routing channels, and we can say SRAM blocks, and we have logic gates, and we have muxes, flip flops. Okay, all these blocks are programmed in this case, right?